Hey everybody, and welcome to the Daily Space Weather. I'm your host Dan, aka Smash a Mash, coming at you from the Smash News Network, least busted name in news. So thanks for tuning in. Thanks for stargazing with us, taking close-up looks at the closest star. We've got an M-class flare to cover. You might see that happening in the northwestern limb up here, as the most active sunspot of the past month is currently setting. It's already set, actually, but don't worry, more sunspots have already risen in the east. Here's a close-up of that area, and that was certainly an active sunspot. It could indeed traverse all the way around the far side of the sun and come back to say hi once again. We'll be keeping you posted on that. And let's go around the horn briefly here. We're looking at, by the way, these are 24-hour videos, 171 plus 211 angstroms from SDO. Very unstable looking filament down there in the southwestern limb. It looks like it's moved but still stayed attached, at least as per that video. Or it could be in the process of ejecting somewhere down here. We've also got a crown prominence going on at the moment at the north solar polar region. The north heliographic pole. We'll show you that soon. Huge filaments on the Earth-facing portion of the solar disk. This one down here needs a name, by the way. We've been naming filaments after living people. And we like these wavelengths because they show great depth to the solar corona. A very bumpy place full of turbulent magnetic fields and hot gas. So these two species that we're looking at here, these are both species of ionized iron. 171 angstroms is good at showing the lower corona, and 211 angstroms is good at showing the extended corona and coronal holes. So also some serious instability with this sunspot right here and the plasma that's leading it. And let's show the full disk view here. Again, that's the past 24 hours. And let's take a look at sunspots, as we've got like 10 named sunspot groups here. And we've got umbral growth since yesterday. So this group here that's now setting, that's now becoming much more likely to produce large flares. As you can see there, it's grown a lot. And as it gets closer to the limb, the statistical probability of it producing a large flare indeed goes up. So yeah, a little bit of growth in this area back here. This sunspot here is pretty large. And the latest one to rise up here in the northeast is decent sized as well. So also an equatorial sunspot down here. It's degraded a little bit since yesterday. This group down here south of the equator has grown a little bit since yesterday. So certainly lots of stuff going on. And if you're very worried and concerned that the sun is shutting down, let me allay your fears right now. It's clearly not shutting down. We're expecting a solar cycle greater than solar cycle 23. It's off to the races. And we've got a long way to go to solar maximum. If there are YouTube channels telling you that we're already at solar maximum, make sure you press the subscribe button and follow our channel instead as we cite facts. Let's talk about volcanoes, but first let's talk about our mission. So you can read about our mission at smashamash.com/forum. The forum is completely free. Smashamash.com/forum. We created a massive infrastructure to support our operations. And the reason for the videos is as follows. It's to assist, study, and report on the ongoing formation of a unified theory of physics, to raise the awareness of the general public of the relationship between space weather and Earth effects. A lot of people are not aware that the sun could do things like shut down the power grid and black out radio communications. Also to connect and consult with media organizations to multiply our reach. Press the share button and assist us with mission number 3. Number 4 is to demonstrate cutting-edge proof-of-concept solutions to problems. We grew potatoes indoors over the winter. Maybe we'll have to make a video about that. Also to publish scientific papers in a multidisciplinary manner, including but not limited to the sciences listed before you there, as they're all relevant to this stuff. To assist mankind by advancing the study of predictive phenomenon, of course, that is what science is all about, predictive phenomenon. If you can't forecast based on your hypotheses, and more importantly, if you can't explain your hypotheses in simple terms, your hypotheses might be nonsense and perhaps should be abandoned. If all of the evidence refutes your hypothesis, it's probably invalid. Anyway, we want to optimize value, reduce risk and liability, and save lives and resources, and adapt no matter what the adversity is. And lastly, not be ossified in our beliefs and treat those who are with love, respect, and inclusion to the scientific discussion because, well, if you're ossified on your beliefs, you're not doing science, you're doing dogma. And at the Smash News Network, least busted name of news, we don't do that. So let's take a look at volcanoes here briefly to see what is erupting here on Crescent Earth. So Shivaluch is exploding, producing a 17,000-foot ash plume over Kamchatka. It's a flight level 170. Suwanosejima, flight level 060. It's a 6,000-foot ash plume. Flight level 070 from Dacono. Sporadic emissions of volcanic ash at Popocatépetl in central Mexico. No indication of an ash cloud there. Fuego in Guatemala producing a 15,000-foot ash plume as it explodes. Flight level 150. Flight level 250 over Peru from Sabancaya as it explodes. Please do not pole vault the caldera, and please do visit the links below the video. For example, our Red Bubble shop includes a public service message. Do not pole vault the caldera, so please don't. We need the views on YouTube. And if you're taking a volcanic vacation, please leave your vault pole at home. We'll also look at global seismicity. Here is the past 90-day bar graph, conveniently collated here by Volcano Discovery. And thanks for leaving a comment, Mike Bordages. Continuing on to our earthquake coverage. No major quakes over the past 24 hours. In fact, it's been light on quakes for the past 24. Indeed, a 5.2 did strike Tonga. But we've got a low number of quakes and a low magnitude of quakes for the past 24 hours. It is an earthquake and volcanic downtick over the past 24, I would say. So here's another series of wavelengths from SDO. This is 171 plus 131 angstroms. This is great at showing plasma orienting to magnetic fields. So you may see a lot of lines there that look just like potential field surface source lines. Well, those are indeed potential field surface source lines. Again, the plasma aligns to the magnetic fields. A great example of that in those two wavelengths. By the way, if you didn't see yesterday's video, make sure you check that out. Press like, subscribe, share, etc. If you're new to the channel. Thanks to our longtime subscribers for tolerating the pathetic, putrid, and disgusting censorship on the YouTube platform. If you're viewing on BitChute, you're missing most of the content, including the recent new playlist, Space Weather Rager. Again, if you haven't seen yesterday's video, here's a little teaser. Possibly the best footage that we've ever put up. So here's a little teaser for you. If you didn't watch yesterday's daily space weather video, it's pretty serious. Anyway, if you want to support the channel, consider becoming a member of the Smash Team at smashomash.com/Smash Team. That's the official subscription services site of the channel. And of course, we need your assistance to keep these videos publicly visible, free for all to view, etc. So consider becoming a member of the Smash Team, and especially the gold or silver level. That helps us to plan for the future and plan for these videos to continue to exist. So smashomash.com/Smash Team. There's also a bronze level. We do send out email alerts for natural disasters. And of course, for gold Smash Team members, you can get an email address at smashomash.com. If you want like Steve at smashomash.com, just sign up for a gold membership. The best value is the annual paid-up subscription. The one-year membership, it's almost like getting 4 months of a gold membership for free. And let's get back to space weather here as, important stuff going on. A big uptick in the 10.7 centimeter radio flux, now up to 182 solar flux units. And we're expecting that to continue to increase today. We're going to be near 200 solar flux units by the end of the day. The black line there is the 10.7 centimeter radio flux. And if you're new to solar sunspot activity and so on, the radio flux is a proportional data set to sunspot number. You might be able to see how proportional the red line and black lines are there. The red line is the sunspot number. The black line is the 10.7 centimeter radio flux. Yeah, the upper chromosphere and lower corona emit radio frequency that varies as per solar cycles. They are directly proportional data sets. And let's continue on here. Talking about the Space Weather Enthusiasts Dashboard, which is forecasting a little bit of geomagnetic storm conditions late tonight and early tomorrow. Also geomagnetic unrest into Tuesday. So expecting some geomagnetic unrest conditions because of a high-speed coronal hole wind stream. It looks like a second pulse just showing up here in the past few hours. We'll be keeping an eye on that for you. And when I say eye on, well, pardon the pun. Here's Earth's magnetic moment from space for the past 4 hours. We show it daily on the channel. It's our geospace magnetosphere movie. We do have some variations in the solar wind coming in here. So that is the magnetohydrodynamic pressure model, the space weather modeling framework. Again, it is the last 4 hours. And again, some variations in the solar wind there, creating some perturbations in the magnetic fields, in the magnetohydrodynamic pressure, I should say. Next, Earth magnetic moment from the ground. So here are our ground magnetic perturbations maps. These will show you the most likely places to see the aurorae, also the most likely places to see pipeline, railway, power grid induction, telluric currents. The past 4 hours, Earth's magnetic moment from the ground. So sticking with Earth's magnetic moment here, this is the KP index, a measurement of global geomagnetism. Currently, geomagnetic calm conditions at 3. We may see this change. We are seeing a strong negative BZ signal. Well, it's at least a fairly significant negative BZ signal. Let's get to the real-time solar wind next, measured at Lagrangian 0.1. So let's check and see about the ACE and Discover. We are seeing some pretty significant swings here in the solar wind parameters. So we are seeing a signal here of about 13.5 protons per cubic centimeter for solar wind density. So this looks like a second coronal hole high-speed stream pulse. We still do have an elevated solar wind here at about 570 kilometers per second. Solar wind density here, 12.5 protons per cubic centimeter. And this top pane up here, you see this negative BZ right there, that negative 6 on the red line there. If we see that turn into a solid signal, which we may, because again, there is a second pulse here coming in from a coronal hole high-speed stream, we may see geomagnetic unrest or storm conditions, minor storm conditions, proceed. So that's the current situation for the solar wind and so forth. Also, I would note these changes in plasma temperature. Those help to corroborate these other signals, which the system is thinking may be some errors. Anyway, let's move on here to magnetic data. And you can see these sawtooth patterns showing up here. That is a characteristic of coronal hole high-speed streams typically. We've got some other forecasts coming true today as well. No real surprise to our regular viewers. And let's take a look at the heliospheric current sheet. Now, actually what we're looking here at is 11 years ago. So this is today. That's actually March 1st through March 5th, 2023. And we just wanted to show you March 1st through 5th in 2012. So going back 11 years, the approximate length of a solar cycle, we are seeing that, well, there are a little bit more current sheets happening back 11 years ago. As you can see, there are 2 South Pole current sheets and 2 North Pole current sheets there. A little bit different than what's going on now. Again, that's, let me scroll up a minute. That's March 1st through March 5th, 2012. And interestingly enough, there's a lot of polar magnetism here at both the south and north heliographic poles. So you see those green parts with the lines through them, that's the South Pole. The solid green is the North Pole. And you've got a little bit of South Pole showing up here, but interestingly enough, you've got North Pole magnetism at both the North and South Pole at this point 11 years ago. Looking at today's imagery, you've got a lot of North Pole magnetism at the North Pole, and you've got some South Pole magnetism at the North Pole as well. So keep in mind, folks, there still is a long way to go as we have almost no North Pole magnetism at the South. You can see only tiny little bits of green with stripes on it. That would be the south solar heliographic polar region. And of course, we only have 2 current sheets here instead of 4, like we had back in 2012. Also, note the positions of stereo A and stereo B. Look at stereo A is way over here. Stereo B is way over here back then. And now they're right by the Earth, which doesn't help as far as forecasting the trajectory of coronal mass ejections. So that's a great tool that you can use on the Gong 2 data. This part of the National Sunspot Observatory. It's very useful for forecasting. And let's take a look at our line of sight field plot. That's the past 5 days, March 1st through March 5th. And next we'll move to coronal holes. So coronal holes are super important because they show us the solar polar field reversal process. And there is a North Pole current sheet headed this way. Let's go back a minute here. So there is a North Pole current sheet headed this way, but it's taken its good old time, an indication that we're going to have some fireworks in the northern hemisphere. And that's what we are seeing now. We are seeing an indication that lots of sunspots there in the northeast. That's our line of sight coronal hole plot. We'll also show the 211 angstroms wavelength for the past 24 hours from SDO. And the coronal hole high-speed stream that we're currently getting is from this coronal hole right here. It's quite large and cavernous. It's quite large and cavernous, like the void of nonsense about space weather on YouTube. It's pretty sad. A lot of channels out there are indeed holding people back in terms of their understanding of cosmology, astrophysics, heliophysics, etc. It's pretty bad. However, we punch up at channels that have 6-figure subscriber counts, and they don't respond because they certainly don't want you to know that our channel exists. Let's continue on to sunspots next. And we've got like 10 named sunspot groups here. At least 9 showing up there on the solar flare probability chart. And we've got various places here that could produce large flares. So namely 3243. Also 3244, it's showing a pretty high probability there. That's got to do with magnetic field complexity. Also this group right here, 3242, is quite magnetically complex. This group here is pretty magnetically complex. So there's definitely a lot of stuff going on. Likelihood of large flares remains very high. I would say the most likely spot would be from 3242, as it's showing very volatile plasma, especially in its leading portion, and 3243. So 3242 and 3243 are my favorite choices for large flares. Here's the past 24 hours in SDO continuum plus 171. Here's a little zoom in. And we did cheat a little bit to the north there since that's where most of the activity is. And of course, one of the features of solar max is that you can expect to see sunspots at all the latitudes. As you approach solar minimum, you'll see sunspots forming more and only around the equator. That's what you see during a ramp down to solar minimum. At solar maximum, you see sunspots at all latitudes. And we are still not there. However, it is on the way. Let's subtract the 171 angstroms to show you the last 24 hours of umbral behavior. Once again, this new sunspot that just rose in the northeast is magnetically complex. We'll show you high-res imagery of that before we get to our meteorology segment. And let's move to flares and energetic particles. Let's talk about the difference between solar flares and coronal mass ejections once again. The difference between solar flares and coronal mass ejections, folks, is that solar flares are X-rays. X-rays are photons. They are high-frequency ionizing part of the electromagnetic radiation spectrum. So they're kind of like light. So turn on a flashlight, shine it in your face, all right? That is a low-frequency version of a coronal mass ejection. If it was an X-ray, it would be a solar flare. Now, keep in mind the Earth's atmosphere filters out X-rays. They can't be measured from the surface except via mitigation of the D layer of the ionosphere. You can't measure X-rays directly from the surface of the planet. Again, they're filtered out by the mesosphere. X-rays, those are solar flares. Coronal mass ejections are when gas blasts off of the sun. So turn off your flashlight and turn on a fan. That diffuse difference in your air, that high pressure caused by the fan, that is like a coronal mass ejection. And X-rays are what a solar flare is. So please understand the difference, and please visit our links, as you'll save 20% site-wide on the Redbubble shop as a happy birthday to Redbubble itself. So happy birthday to Redbubble. Great products there. The print quality is very, very high. People are very happy with the products. Perhaps pick up a very, very plush Fauci Face of Evil fraudster bath mat and put your feet on the face of evil daily. Or tell your friends and foes to do the math. Maybe they suck at it. I don't know, but it's certainly an interesting equation. 8 = capital D, because reasons. And congratulations on surviving a global pandemic so far. Today's featured product is Do the Math. Again, you can save 20% site-wide. So visit the links below the video. And of course, on this one, we featured the galactic core, because people are scared of all kinds of things in space, and one of the things that people are scared of on YouTube is the galactic core. They think that the galaxy is just like the solar system, which couldn't be farther from the truth, and you couldn't be farther from the galactic core at about 27,000 light years, which means the sun's not interacting with the galactic core in any meaningful way. Keep in mind, galactic rotation takes about 250 million years estimated time, and again, the galaxy is nothing like the solar system. Things are really far apart in space. So if people are telling you that the universe is electric and that everything's connected, I would remind them that you are not quantum entangled with a thing that you can't measure. So like when a Jupiterian moon goes behind Jupiter and you can't measure it anymore, guess what? You're not entangled with it. Everything is not connected and the universe is not electric. Get off it. It's just utter nonsense. Don't tolerate cosmology nonsense. And if you're unable to, do the math about Sagittarius A star. Again, it's very far away at about 27,000 light years, and it is not controlling the sun's behavior. Next, the GOES proton flux here remains flatlined. So we've seen a ramp down of our latest solar energetic particle event, or SEP. Since then, no spikes in the proton flux. Some spikes in the X-ray flux, though, indeed happened. We did see a large M-class flare yesterday over an M5 level. And a small flare happening right now. Looks like it's leveling off before it gets to M-class. We'll show you that imagery here in a minute. First, some more 24-hour videos. Because, hey, it is the daily space weather. And since the source of space weather is the sun, there's 94 angstroms. Can you see that M-class flare there coming from the northwestern limb? Here's 131 angstroms. Just up and to the left of that Earth scale image there, you'll see that M-class flare right there. And that, my friends, is some fine imagery. Some fine imagery indeed. Next, let's take a step back and orient ourselves, as there's lots of talk of planetary conjunctions. If you're up before dawn, you might see Mercury and Saturn close to each other there in the sky. And if you're looking at the sky after dusk, you might see Venus and Jupiter, the third and currently fifth brightest objects visible. Mars a little brighter than Jupiter right now, as Mars is much closer in the solar system. And the sun here only a few degrees off the horizon there over Lehigh Valley, Pennsylvania, currently in the constellation of Aquarius, which means something to somebody who does astrological charts for some reason. Next, Solar system forecast. Here's where stuff is now. Earth is in a lonely portion of the solar system as Mercury and Venus speed around to catch up. Let's do a 1-week forecast here as we're approaching a full moon. There's where things will be on March 12th. How time flies when you're producing the most detailed imagery of the sun and comprehensive space weather you'll find in the known universe. Who knew we would accomplish so much at the Smash News Network, least busted name in news? Next, we're going to look at some coronagraphs, as we had some spectacular CME activity that you see right there. So that was from yesterday, a great coronal mass ejection there, blasting out. Looks like it's off to the west. Let's take a look at today's images as well. There's 39 more frames from today, March 5th. And we'll show you more views here from Stereo A and Soho Lasco C3. So we paused it here at 1842 for Soho Lasco C3 and 1838 for Stereo A. There is a concurrent event sort of happening here on the opposite side of the sun, it looks like. And as far as this being earthly directed, it looks like two separate events. So it doesn't really look like an earthly directed CME. It looks like there's something on the opposite side at the same time, not an earth directed event. So a great fireworks display though. From El Sol, Helios, the closest star, the sun, the local yellow dwarf, whatever you'd like to call it. And let us know in the comments if you think the sun is conscious. Maybe we got to do a video about that, as we've seen repeated things happen on the channel. Events occurring at the same time as we stream live and so forth. That's always a delight. Let's take a look at some 24-hour videos. Here's a great example of several different coronal mass ejection events happening in a similar time frame. There's a little closer zoom in. And typically when you do see an earthly directed coronal mass ejection, there is some indication from this SDO wavelength. You'll see something like limb brightening, or you'll see a filament move or something like that. But nope. And next we'll talk filaments, because there are certainly a lot of them. So you might be able to see them in this wavelength. This is ionized helium by itself, 304 angstroms. And you see all this instability happening right here. By the way, this filament down here is the Brian Keating filament. This one here really needs a name. So you're invited to Twitter to name that filament. You'll find us all over the internet at Smash-O-Mash, and let's add 193 angstroms here to add a little bit of additional contrast to bring out the character of those filaments. So there's 193 angstroms included, and you can see a little bit of additional detail there of all of those filaments, and there are certainly a lot of them. Over there, setting in the west, southwest, you've got this is the Hillary Clinton filament down here, and then you've got the Kamala Harris filament right up here, and then this is the Brian Keating filament right here, and this one here needs a name. So you're, again, invited to name that filament. If you haven't joined us on Twitter, make sure you do. You'll miss out on a whole bunch of things like auroral imagery and various other stuff that has nothing to do with space weather. And here's our filament view from Cerro Tololo, Spain. So if that didn't provide enough detail for you, here you go. The hydrogen alpha imagery, it shows filaments as absorption features here, which is why they're dark. And then when they're hanging off the limb, like the Hillary Clinton is starting to down here, they become what we call prominences. They're still the same feature. They're plasma suspended by magnetic fields in the solar corona, defying gravity with their magnetic fields. Anyway, highly recommend you name that filament, as it's right in the Earth-facing portion of moving right into the Earth-facing portion of the solar disk as we speak. So you are indeed invited to name that filament. Again, you can only do it on Twitter. If you don't have an account, make sure you get one, since filaments are a super important portion of space weather. No, Elon Musk has not fixed censorship. Shadow bans continue on Twitter. We've only got 389 followers, over 19,000 tweets, and we've been on Twitter for over over 4 years, or pushing 4 years now. So, censorship is not fixed. Shadow bans continue, as Elon Musk has stated. If you think Elon Musk has repaired free speech on the internet, please enter into reality. And if you think the sun is shutting down, please enter into reality, because you see all the activity? We're not even at solar maximum yet, kids. So don't be a space noob. Look, a crown prominence. It's just a tiny one, though. You can expect some really beefy ones when we're actually at solar maximum. Anyway, there may be a CME happening right here, although it looks like this plasma has retracted again. So that happens sometimes. It could be an ejection, but it looks like if so, it is a minor one, as it may have succumbed to gravity. So anyway, that's the past couple of hours there in the GOES 16 SUVI's 304 angstroms wavelength ionized helium. And we'll likely be streaming this later today on the Twitch channel at twitch.tv/smashomash. So here come bonus features, satellite charging hazards. We've got some significant ones here. Some significant surface charging hazards in the Central Pacific, and some minor internal charging hazards here in the Central Atlantic and Central Indian Oceans, also over portions of northwestern Australia. Some charging hazards there of both the internal and surface charging variety. Internal are caused by high-energy electrons getting inside of spacecraft, and surface charging are caused by low-energy electrons building up on the outside. Some communications errors could follow. Next, a minor electron storm happening here. We do have the GOES 16 in electron warning levels and the GOES 18 toying with them. That's our GOES electron flux measured by the GOES 16 and GOES 18 from their geosynchronous near equatorial orbits using radiography. They measure it at the F layer of the ionosphere. Here's the forecast model. And NOAA expecting a little dip here. I would expect a little larger dip, but no major arguments there. We are expecting a little bit lower levels here, especially if we do see another signal of a coronal hole high-speed stream. There's the 1-year chart to put that in context. That's the greater than 2 mega electron volt electron fluence reported by Solon.info for the past year. And let's take a look at the layer of the ionosphere where it's measured. About 300 kilometers is where the bridge between Earth and space is, the F layer. Whoops, we'll show vibrational frequency and anomalygram. So there is your ionogram. Again, we show it daily on the channel because all of the data sets that people conjecture about and or don't understand are data sets that we're interested in deep immersion into. As fun fact, when you immerse yourself into the data, you have the capability of ending up with answers to questions not asked. So you're more likely to end up with answers to questions asked. Also, if you immerse yourself in the data and understand the physics relationship between the various phenomenon. Otherwise, you'll probably just be looking at stuff and going, whoa, dude, it's so rad that you can forecast earthquakes by looking at the ionosphere. Well, if so, why not forecast earthquakes by looking at the ionosphere? I'm not convinced, although we may have actually forecasted some a few days ago. Watch our previous space weather videos for information on that, as we only include limited information in the thumbnail and title, encouraging people to actually view the content. I know it sounds like a crazy idea, right? Well, certainly viewing a lot of nonsense on YouTube is a crazy idea. Here's the latest image, 1400 universal time ionogram and 1400 universal time anomalygram. We'll also take a look at the total electron content forecast, showing you the most likely places for GPS errors. And exactly as we forecasted, we do have some polar GPS errors likely here, especially around the North Pole. So that was forecasted yesterday. We stated that when the coronal hole high-speed stream arrives, we can expect to see some perhaps unexpected GPS errors. And indeed you do. So this is another typical thing. We've covered it for years and years on the channel. We're able to forecast all kinds of things, and we do on a daily basis on the daily space weather videos. Once again, congratulations on realizing the channel exists. And Thanks for making it this far into the video, as there's still plenty of stuff to cover. Let's move on to look at our latest solar intensitygram and solar magnetogram. So first we'll look at this new sunspot that just rose. It is magnetically complex. It is a beta-gamma class sunspot group. It might even already be beta-gamma delta class. In fact, if I had to guess, I would say it is beta-gamma delta class. Excuse me. Also, let's take a look at this setting group up here. Wow, that is magnetically complex. That's beta-gamma delta class as well. So again, that one's getting more and more likely to produce large flares as it approaches the limb. This group down here, it's very oblong. So what's interesting about this one is that it's got leading South Pole umbrae there that are all spread out, and then a concentrated North Pole umbra trailing it. That's actually beta-gamma delta class. So again, just like the flare probability monitor shows, that is indeed likely to produce large flares, especially as it approaches the limb. Also, we've got, man, these groups up here are magnetically complex as well. Those are, even if those are only alpha class, they are certainly complex in their fields. And I still think this sunspot is the most likely place to see large flares. Let's just take a look at that in both intensitygram and colorized magnetogram. There you go. Very large leading North Pole umbra there, trailing magnetically opposite umbra there. It's beta-gamma delta class. And here's your full disk rock back. And that brings us to meteorology. So our meteorology segment is next. And if you haven't checked out the links below the video, you may find a link to the Hemp Lucid shop. So our latest affiliate/sponsor is Hemp Lucid. Great products there and a great affiliate/sponsor. So if you're just shopping on hemplucid.com, if you want to tell your friends and foes about us, tell them to use the promo code SMASHOMASH on checkout. SMASHOMASH to save some cash on checkout. And you can also use the link below the video. Also, if you want free mushroom gummy samples, I refer you once again to Twitter, as the link to our free mushroom gummy samples is listed. It's pinned to our Twitter profile page, so you don't have to scroll down. So save some cash via that. Try out the mushroom gummies if you've never tried them before. Various different types of mushroom gummies there for sleep, for focus. Also immune stacks, all kinds of different products that you might not be aware of, like body balms, lip balms. They are doing well, and it's a great affiliate/sponsor. Thanks to Hemp Lucid and to everybody who's been smart enough to pick up some products. It is a good times indeed. Visit the links below the video to also find SmashOmash.com. It's the official homepage of the channel, the official homepage of the Smash News Network, least busted name in news. Once again, congratulations on realizing it exists. I guess I must have said something that wasn't a complete lie about certain immunological things a couple of years ago, as you might have noticed that our subscriber count has stagnated just a little bit. So help us out with clicks if you're unable to become a member of the Smash team, etc. Of course, you are able to become a bronze member, so sign up for email alerts there. Hemp Lucid link there as well. Links to the Twitter feed, Instagram, to the Twitch channel, to Patreon, and also a permanent invite link to the Discord chat. So if you want to send an instant message, do it over there, and let's get to meteorology. Here is the total cloud water. Okay, so one of the many features of nullschool.net. It might look boring, but I like it. It's the total cloud water. If you want to see where the water is located, of course, that is a potent greenhouse gas. Yeah, water. Maybe you've heard of it. It's what clouds are made of. You may not be aware of this, but did you ever notice that it stays warm on a cloudy night? You know why that is, right? It's because of the greenhouse effect. Yeah, clouds, they radiate infrared radiation. They emit infrared radiation. That's why it stays warm at nighttime when it's cloudy. And that's why it gets cold in the desert at nighttime, because it's usually clear in the desert. And let's get to our regularly scheduled meteorology segment. So we're going to blast through meteorology here. Here are the surface winds of the eastern world. Here are the jet streams of the eastern world. Here are the jet streams of the western world. And let's don't forget the surface winds, like sands through the hourglass of time. These are the surface winds of our lives. Here are the surface winds of the central world, Europe, Africa, and Asia. Well, the Middle East, at least. And these are the jet streams. Continuing on, here we've got clouds and fog over the Americas. Shout out to our viewers from all around the planet. Who knew we would make so many friends and anger so many cosmology hacks? I don't mind. They'll come around because they'll realize that we were right the whole time. It's only a matter of time. Anyway, that's clouds and fog over the Americas. Let's continue on to our weather.gov map. If your location's lit, click your location. That is too many counties and waterways for us to cover in the video. But we have been kind enough to scroll down and show you the key. Weather.gov, once again, is the location. Weather.gov. Here are some forecasts. This is your temperature anomaly forecast based on the GFS model for the next 72 hours. We show 72-hour forecasts on the channel because they are accurate. We don't show like 380-hour forecasts because 380-hour forecasts are completely inaccurate and ridiculous. And of course, we've seen it on thumbnails, and there are certain channels that we refuse to unsubscribe from on YouTube just because we want to see their ridiculous thumbnails, not watch their content, and then leave comments about how idiotic they are. Here is our pressure and precipitation map based on the same model. It's the 72-hour GFS model. And heavy snows continue to strike places like Tahoe, Big Bear, and so on. Eastern California, it just keeps snowing and snowing and snowing. We've got a snow report coming here. So here is your total accumulated positive snow depth change in inches based on the same model, the GFS 72. GFS 72 hour. And again, we're pushing 3 feet of additional snow there forecasted for California. And some snow coming to Pennsylvania here. Lehigh Valley expecting an inch or two. As we've had about 5 or 6 winters here in the Boston to D.C. corridor with almost no snow. So incredibly low snow totals despite 7 winters in a row of very high snow totals for the Northern Hemisphere. And let's take a look at that next. So here is your snow depth from windy.com. Of course, you may be concerned that Greenland is going to melt. Let's see how much snow is on top of the sea ice right here. And, it's only 115.9, only 112.6 inches of snow there, folks. So it looks like Greenland is going to melt. By the way, leave us a comment if you want to see Trump purchase Greenland, start a Greenland water company, and build some golf courses where you can play golf, where you can golf on an ice sheet with an orange ball. I want to see that be a thing. I would so go on vacation there. Greenland Trump water. Let us know what you think about that. I'm sure it'll enrage half of the audience and enamor the other half of the audience. I don't really care. I'm completely apolitical, if you're wondering. Never been associated with a political party and probably never will. Anyway, here's our Global Cryosphere Watch snow update because we want to show you that it is indeed a 7th winter consecutively with record snowfall in the Northern Hemisphere. So a lot of people have been stating that snow is going to stop in the northern. Snow is going to be a thing of the past as of 2020. Look at the snow water equivalent just going off of the chart here. So it's well over 1 standard deviation above the 1998 to 2011 average there. A lot of snow, indeed, is currently on the ground. Now, as far as the two-dimensional portion of it, we actually have less snow than normal. So as far as snow extent, which is just a two-dimensional, practically meaningless thing, it's just showing you the area that's covered on a two-dimensional basis, it's actually less than normal. And then, if you head to this is the snow mass equivalent, the snow mass balance for the Northern Hemisphere. And this excludes mountains. So check it out. It's well over 1 standard deviation above the 1982 to 2012 range. It is a 7th consecutive winter with record snowfall for the Northern Hemisphere. That's just a fact. I mean, look, there it is. There it is. It's an empirical fact. Now, of course, this graph needs to be changed because the graph is so old, 1982 to 2012. In other words, that standard deviation line is actually over 10 years outdated by this point. However, based on that average, it is a 7th consecutive record snowfall year for the Northern Hemisphere. Continuing on to some more real-time data here, or near real-time data. That's the past about 10 hours of our NASA GOES lightning mapper. Pretty calm here in the western portion of the planet. And there are some active cells in the eastern Mediterranean, the central Pacific, and near the coast of Africa. But besides that, according to lightningmaps.org, not a lot of lightning currently striking. Next, your U.S. Doppler radar map. So that's what's going on over the 50 states of ALSA, the allegedly United States of America, former nation, now banana republic, rife with corporatism, corruption, and plutocracy. You're living in a corporatist plutocracy, folks. Accountability always comes one way or the other, though, so prepare for that. As, again, let me just reiterate. Accountability always comes one way or the other. You can fool some of the people some of the time. You can fool all of the people some of the time, but you can't fool all of the people all the time. Here's clouds and fog over the lower 48. A bunch of low clouds here over the North Atlantic. And this is the water vapor map. It shows all the water vapor. A little bit of moisture being compressed there in Oklahoma, likely causing some precipitation. Let's see. Not yet. But there is a huge pressure gradient being created there indeed. Anyway, that's the vertical motion of water droplets in the air column, also ice crystals. Here is clouds and fog expressed as 3.9 nanometer infrared radiation. And there is water vapor. Anyway, once again, thanks for tuning in to the Daily Space Weather. Congratulations on realizing the Smash News Network least busted name in news exists. In the meantime, I've been your host, Dan, a.k.a. Smash-a-Mash, signing off. And may that solar wind be at your back. Please don't forget to visit the links here and here and here.